Hello everyone, this is Dory from finetuners.ai, and today I want to show you how to build a machine that creates infinite variations of solitaire card. And as you can see, we keep the original color, numbers and suits intact. We just change the composition of the card. So I'll show you how to do it, but before we jump into ComfyUI, which is our tool for the task, I want to go over the architecture of the whole thing. So to create a solitaire card that remains true to the original font and number, color and suit, we need to create a deck of template cards, 52 cards that will give us the basic composition of the card. So this would be the first step. Then we will use ControlNet to keep the structure intact. Then we will use IPAdapter to get the color right, and then we tweak the different parameters until we get the cards we want, and then we apply it on the whole deck. Okay, let's go to ComfyUI and see how it's done. And so this is almost the default settings for ComfyUI. Let's go over it left to right. I begin with the checkpoint, of course. I'm using Cheyenne V16. It's an Excel model connected to a LCM LoRa, because we want to have fast generations and to be happy in life in general. Then I've added a few reroutes just to help me make the flow just a little bit more in order. Negative and positive prompt, a cartoon, anime, magic mushroom, landscape at dusk, high contrast and dramatic, graphic novel illustration style, dense fog, vivid colors. We have an empty latent image set to my card's default size, which is 648 by 888. And the K sampler, which is aligned to the LCM settings, which means that we are generating very fast. We're using only 6 steps with a CFG scale of 1.5. And let's see what it does, how it looks like. So, yes. Beautiful, and we would like to apply this style only to make a solitaire card out of it. So the first step would be to do a simple image to image, but with a batch of 52 solitaire cards that are very basic, but have of course the number, colors and suits. But for this tutorial I'm going to use the sample folder, which has only 2 cards. So I'll copy the path to my sample folder. It's local on my computer, and let's add a node, load image list from directory by Inspire. This will load the images one after the other. I'm pasting the path to my directory. Let's have also a reroute here, so it will be easier for us later on. And now we need to encode these images and get them into the K sampler. So here's the VAE encode. We connected to the VAE pipeline, and this goes here. So let's see what we get. So now we have 2 images, and they are very nice, but we don't see numbers or suits or the cards, and this is because we are using a very high denoise. So let's reduce noise and go with 0.8 and see what we have. So this is actually very nice and artistic thing. Of course, we need to see the numbers and suits. So to do that, I will add a ControlNet to preserve the structure of the actual card. So let's make room for ControlNet. Step aside. Apply ControlNet Advanced. Okay, this ControlNet needs a ControlNet model, so we will use the ControlNet loader, and I'm looking for Canny, and the image. So we need the preprocessor, and here is the Canny preprocessor, and the Canny preprocessor will get the images from the image pipeline, connecting to the control net, and the conditioning, we will connect them as well. Okay, control net. Now let's see. Okay, so now we get very little style, but we get the original shapes and even colors. So we can control that and add or deduct style by reducing strength and of course playing with the denoise as well. So we can go with less control net strength, and then we get a little bit more, and let's use more noise. What happened? Oh, sorry about that. So as you can see, it is still not perfect. We are losing the numbers almost instantly. And we need to fine-tune it better and to give us some more control. So we will use IPAdapter, but before we use that, we can also do something with the latent image that we send to the model. So currently it's really very white. It looks like this. When using image to image on an image that is mostly white, well, it is a very definite color and the model doesn't really know what to do with it, so it's very unstable. But if we would change the color here, we would get some kind of a control over the generation color. So let me show you. Let's add a latent blend to the mix. And we will blend the images with the empty latent, and we will send the blend currently on 50%. We will send the blend to the K sampler. Now let's see. So now, as you can see, we do see the numbers better than before, and we will have more control over how much style we get eventually in the card. So let me just show you how it works. This will be only a sample for us. Let's do a preview. And you see that the white is now off-white, and I can give more emphasis to the white card or to the empty latent. So let's try like this. So now we will have much more style. We lost the numbers, so we can set this back to 1, have less noise, okay, we're beginning to see the shapes here. We can also play with colors. So I'm loading an image and I'm just loading a solid color. Now I want to blend it with the original card, so let me encode it real quick. VA encode, connecting the VAE pipeline, and we will replace the empty latent, this one, we will replace this with our solid color. Now we have a bluish image, and we also have a bluish card. So this is very nice. I think I'll keep the image here. So let me get rid of this. We don't need the sampler anymore, the preview anymore. Image here that is getting in the mix together with the white image, creating this kind of blue image, which then gets an image-to-image treatment, and we see this. But of course we need a better solution for the numbers and suits, because we want to keep them in the original color, in the original shape as well. So for this we will use IPAdapter. So let's make room for IPAdapter. I'm using the IPAdapter Advanced, and IPAdapter Advanced needs an IPAdapter model. I'm using the unified loader. I'll use the plus high strength one, connecting it to the model pipeline. Goes here, and to the K sampler. Images we will take from the original. We don't want the blend, so I'm going to take it exactly from the original, from the image pipeline. And we also need to have an attention mask. I want the IPAdapter to take influence only from the actual number and suit. I don't want it to take influence from the white interface of the card. So let me mask the card numbers and suit so it will be more accurate. How do we go about doing that? There is a node called image to mask, convert image to mask. I'm taking the image pipeline and connecting to it. The channel will be green because we don't have green in the cards. And let's do a mask preview. Let's see how it looks like. So we definitely have a mask, but the question is what is the mask and what is not, because these colors don't really tell. So we can make a very quick experiment. Loading an image, and I'm opening it in the mask editor. Let's do a mask that we will recognize, save to node, and connecting to the preview. And you see that the mask is the white one. Hence, we are masking the wrong thing. We need to invert the mask. Invert mask. This goes here. Let's see the preview now. And it is now inverted, which is good. So we are sending this invert into the attention mask of IPAdapter. These are also very high numbers, so let's reduce them a little bit. 75 and at 75. And now let's see. Yep, this is almost good, almost good. Now, just to show you the difference, these images were generated with the attention mask. Let me remove this and see how it looks without. So we get way too much influence, and for this reason using a mask is definitely obligatory here. Okay, now I'm going to do something that is a little bit strange. But because we're working with many creative directors who do not want to connect nodes and strings together, I mean, this is a recipe for a heart attack, we sometimes provide them with a controller. So let's make a controller together. I'll start with the prompt. I'm going to drag it here. And we also need our latent blend. And it comes with a color. We will also need the IPAdapter. We need the control net. We need a case sampler. And of course, we want to see the images that we generate. Now I'm going to settings, and where it's written link render mode, instead of spline, I'll keep mine hidden. Now this really focuses us on the different variables we have to create the image, and we can start with how much theme we want in this card. So the less we go with the noise, the less theme we get, and we can adjust it. Now this is very, light, but also if we will change the blend factor, we will get it more white. Okay, it could be something like this. If we want to see even more, we'll go with this. If we feel that the colors of the IPAdapter are not there yet, we can always make it more strong. Very nice. We can change seed if we want to see different examples of the design. We can easily control saturation with CFG. Or vice versa. this was the best. We can change colors. And we can get more interesting shapes if we reduce the strength of ControlNet. Let's go even lower. And of course, we can always change the prompt to get something that is completely different. When we feel that we found something that we like, all we need to do is to change the path here from the sample folder to the whole folder, and that's it. You will have your deck of cards in seconds. And that's it. I hope you like the flow and the way I'm thinking about challenges like this. If you want to try it yourself, I prepared the folder for you containing the card templates and of course the flow, and I'd love to see what kind of designs you come up with. Of course, if you download the folder and you like the video, please subscribe so you'll see me next time, and I'll see you next time. Bye bye.